Oh, everyone's gone quiet. It's lovely. Good evening, and thank you for coming. And thank you to parents as well for attending remotely in our ILC. My name's Simon. I'm the Deputy Head of Maths here at Reigate College, and welcome to our Women in STEM applicant event. This is the second year that we've done this, so it's really good to see that it's as popular as it was last year. I'm not going to talk for too long tonight, because what we're going to be doing is showing you the excellence of our students, and we've got some fabulous external speakers to talk about sort of their work as working as women in STEM. I'm just going to take a little bit of time to introduce, though, where this came about. So I was, growing up, I went to an all-boys school, which I know for this kind of environment is a weird introduction. But I didn't see the sort of the disparity of gender in STEM subjects until I went to university, where I was shocked how few people or how few women were taking subjects like engineering, computer science, maths to some extent as well. And it really hit home to me that, you know, I always wanted to be a teacher, so trying to change that is something that was really important to me. I did a training session a couple of summers ago, presented by some women in STEM, about how schools and colleges can help support this, the women in STEM. And this is kind of what we came up with, was an applicant event like this and a support group for our students. Women in STEM, and it being a, my clicker doesn't work, lovely. Women in STEM being a sort of an issue has not been, it's been around for a long time, and even so long ago as the 1980s, it has been talked about. A charity was set up called WISE for women into science and engineering to support and to help with kind of this, there we go, with kind of this, there we go, yeah, with this. They suggest, through their research, that in order to make significant change for any minority in a workplace or an environment, you need 30% representation. Now, over the last few years, there has been improvement. We can see that, you know, in 2017-18, 35% of female students in core STEM subjects. Physical sciences, very strong female representation. You know, things like biology, chemistry. But then, and sort of the same with mathematical sciences, but it's when we get to those computer science and the engineering and technology where there's really not a lot of female representation. And, you know, that's kind of the big push. Of those students who go to university, only 25% of STEM graduates are women. And again, we can see, although pretty good representation in the physical sciences and maths, very low in the computer science and engineering. And that's kind of, again, a concern. But here's some good news. In the workplace, in 2019, the number of women working in STEM fields passed 1 million people in the UK, which is phenomenal. But that's still 24% of the workforce. And we need that 30% to start making a real change. WISE, the charity I mentioned earlier, suggests that by 2030, if current trends follow, we will have that critical mass. And it's through, you know, initiatives like this that we're doing at college and that universities and companies themselves are doing that's really pushing that. We can see here, again, very similar with that breakdown of the proportions, very low proportion of engineering professionals are women. Same thing in IT. So, you know, really in that computer science and engineering is where we need the big change. A couple of years ago, a charity or another company conducted surveys and found that women were more adversely affected by the COVID-19 pandemic than men, which has obviously, that is something that no one had ever thought about would happen, but it is very much something that did. And it's now companies are bouncing back from that and seeing what they can do. So what do we do at college? Well, last year, we started a Women in STEM support group. Last year, it was very small. We met relatively infrequently, but we kind of made sure those meetings were high impact, so things like external speakers and that kind of thing. This year, it's exploded. We've got consistently 35 students coming every week to these sessions. Not every session is, actively doing something, but it's a useful space for these students to talk about their subjects, talk to each other, and just get to know more people similar to them as women in STEM. We are looking to plan more events. We have events like this, but we're looking to get in external speakers as well. Last year we had a speaker from Deutsche Bank, a software engineer from there, and she's going to come in again and speak to our Women in STEM group at some point this year. We've also got the possibility of ex-students coming in to speak with our students as well. One who I've spoken to already, who's keen, is a current PhD student doing chemistry in Bath. So, quite high-profile STEM alumni. We're also organising some trips. In our first session, when I asked everyone, what do they want to do? What do they want out of this Women in STEM group? Almost everyone said they want to do trips. So I've started to organise one, and we're looking to take the Women in STEM group down to the University of Portsmouth, whose STEM outreach organiser has done a phenomenal job putting together a Women in STEM specific day for our students. So a lot of really, really good things there. Now, as I said, I don't want to speak too much longer because I want you to hear from our students and our external speakers. So what we're going to do, oh yes, I forgot about that. So other things, so success stories from college. These are two of our upper six students, Gemma and Tilly, who have recently completed the Maths Olympiad for Girls, which is a female-specific maths challenge type thing. Tilly achieved a merit, and Gemma achieved a distinction and was one of only 40 people in the country to get full marks on the paper. So we have some very, very strong female students here at college. So what we're going to do first is I'm going to introduce you to some of our upper six students who have last year completed an extended project qualification. These are across a wide variety of subjects. You're going to see some STEM-based ones, some not STEM-based ones, and that's kind of the fun of the EPQ, is you can broadly pick whatever you want. So first, let me introduce Maeve, who is going to be talking about her presentation on Concorde, halted due to poor management or revolutionary engineering. That should be on there. You can maybe go. There's a clicker. Just go.
Hello, so I'm Maeve. So I did my EPQ on Concorde, which is a supersonic plane, and my EPQ was Concorde halted due to poor management or revolutionary engineering? So, me. So there's a little quote to make it look fancy, but so this is what my EPQ is basically about. It's about a supersonic plane, which was the first ever commercial supersonic plane to carry passengers. There's a few facts. It was built by Air France and BA together, and there were only 14 put out there in use over its service, and it retired in 2003, and so my aim was basically to deduce why it was retired so soon. So these are the flights. I first started research on what flights it did. So one was from London Heathrow to JFK Airport. And put a little animation there for you. And then the Air France one was from Paris to JFK too. And then there were some uncharted flights on top of that. So why did I pick this subject? I always knew I wanted to do something to do with engineering. I wanted to do that into the future, so I wanted to be relevant to what I do at uni. And so I looked at lots of projects based on engineering, and I knew my parents had gone on Concorde, so I thought it was quite relevant, and I thought it'd be pretty cool. And these are not my parents. This is a model, and whoever she was flying with. But that's inside. So what did I find? So I researched how it was managed and why it became so exclusive. So for example, Princess Diana went on it, Elton John went on it. It was very luxurious and, all of that. I researched how it's designed, how it's made, and how it was developed throughout the years, how much it cost, all sorts of different factors that went into that as well. There's some pictures. I researched there was a crash, an Air France crash in 2000, and it's quite a significant news story. I researched if that played any part into why it was retired and what that did to the company. I concluded that essentially it was retired because of how uneconomical it was. It was very uneconomical. Not because, however, because people think it was fuel inefficient, because it was supersonic. It was actually for some different reasons, mainly because demand was decreasing for multiple different factors, like the increase in technology, like for example, video calling. People didn't need to use quick air travel anymore, and other things. But thank you very much for listening. That was my...
Thank you, Maeve. So one sort of very based in the engineering and a little bit of the business side of Concorde. We're now going to hear from Angie, who did a very different EPQ. There you go.
There we are. So hiya, I'm Angelina, and I do physics, chemistry, maths, and then English lit as well, which seems like an odd combination, but I promise part of being a STEM student is also knowing that you are allowed to enjoy other things. We don't have to be one-track sort of people. We can enjoy multiple things. So this was my EPQ. I'm probably going to look back a few times because I promise you EPQ students, these titles are very long and you're never going to be able to remember them word for word. But to summarize, basically, my EPQ was about how artists, whenever they create pieces, cannot help but put their own personality into them. We all like to think we create things devoid of emotion or, we can separate ourselves from what we do. But I basically investigated whether or not you could tell if you, knew someone had created a piece. So my inspirations actually came a lot from my English literature course. When you enter year one, you start off with some poetry, but then you move into novels. So you do Frankenstein and the Handmaid's Tale, but honestly, reading Frankenstein, it was amazing. I'd never seen a piece where I was like, you can really tell Mary Shelley wrote this. It was like, God, yeah, I can see. But I remember looking at that and being like, when I create work, can you tell that I've done that? So that was sort of a starting point, and that's obviously very rooted in an artistic place. But as I started to investigate, when you do an EPQ, no matter what you do the subject on, you learn so much about structuring an academic paper, doing research, really getting into sources, because once you enter college, I don't think you can leave without writing at least one paper where you've had to use Oxford citation, get into how credible your sources are. So I basically split my project into two halves anyway, because I created an artifact. So when you do an EPQ, you can just write a paper, or you can do an artifact where it could be, sometimes people do pieces of music. We had a friend, Will, who created a literal rocket. He was like, yeah, I'm just going to build it in my backyard. So that was an artifact. But my one was going to be an art final piece. The actual piece I created wasn't as important to me as the data I got from it. So I created a piece in the style of Renoir, which was where my artistic study came in. At GCSE, I had studied Renoir, and I was like, oh, basically, I can look at that again. It's something I'm passionate about. So I created this oil painting, and I was like, okay, doesn't matter exactly what I've done it on, but I'll show it to my friends and other people and see if they could figure out who had done the painting, because I showed it alongside a lot of other paintings. Now, from my final research, you have to write a conclusion at the end. Long and wordy, but to sort of summarize what I found from that and doing all the data and building like word maps and stuff like that is that you can't separate your personality from what you do. And I think regardless of whether it's artistic or not, you can't separate who you are from what you create. And that's really important, whether it's, art or STEM. A lot of what you love is in what you do. So I produced this art piece, showed it to people, and when you create an EPQ, you're not meant to know the answer, because otherwise it's pointless doing it. But you sort of have a strong guess on what the answer is going to be, and this sort of result matched what I predicted. But so to summarize, an EPQ should be about what you love, whether it's science or art. It definitely is useful to any type of person out there.
Thank you. So, as I said, EPQ, and as Angelina said, very broad. You can kind of do whatever you like on it. And our final student speaker presenting her EPQ is Laura. There you go. There's your clicker. Yep, it's just on the right.
Yeah, so my project was to what extent will the increasing volume of artificial satellites and orbital debris impact humans in the future? It did start off shorter than that, but as everyone who's done EPQ will say, it kept growing. I also do maths, physics and biology, by the way, so it's sort of physics-y related. So what is orbital debris? So it is defined as defunct artificial objects in space, primarily in Earth orbit, that no longer serve any useful functions. And it generally is just all artificial objects, all artificial debris does all originate from Earth. So it is our responsibility to sort of be responsible for all of it. Like you can't, a lot of it just gets sent up. What are we going to do now? That was sort of the general focus of the project. Why did I choose to write about space debris anyway? So, as of the 7th of November, I looked up these statistics the other day. There are at least 36,500 debris objects greater than 10 centimetres, a million debris objects between 1 centimetre and 10 centimetres, and 130 million debris objects between 1 millimetre and 1 centimetre. These are all in orbit of Earth, and I'm about to get into this, but even though those sound really small, they have a lot of energy and they can do a lot of damage. But over the next 10 years, though, this is due to, unfortunately, a bit sadly, get a lot worse with a lot of developing technology, such as SpaceX and Starlink. That's all going to start building up a lot more, increasing by at least 300%. Again, another kind of sad statistic is that in only 16 years, it's actually predicted that 1 in 16 stars in the night sky will actually be a satellite or some sort of object reflecting light from the sun, which is a little bit sad, I think. But I think it's not past the point where we can change things. And then the photo there is a image of all of the track debris orbiting Earth. It shows the relative positions, but not the size, so I just thought it was quite interesting. Pages are sticking. So, got key source here. This is, if anyone's ever seen the movie Gravity, this is actually the paper that inspired that movie. It is the collision frequency of artificial satellites, the creation of a debris belt. It's actually a really interesting paper, believe it or not. So it builds a statistical model of a collision cascade that could occur in the low Earth orbit region of outer space. And this is because when two things collide, that increases the overall surface area of the debris. So one collision creates debris, which then those things collide and create even more debris. And I think that graph just really demonstrates quite elegantly how I don't know if you can see that, but the upper line, the top line is the total debris, and then the line just beneath that is all the debris from fragmentation. So that's like debris from two objects crashing into each other and like sort of splitting off. So yeah, I think that just shows how that is probably the main contributor and something that I really focused on, something that we need to sort of sort out. But yeah, how does debris affect spacecraft? And then above me, you can see what I meant when I said even a small object can really do a lot of damage, because that is concrete. And we can't send concrete to space. It's really heavy. Well, we can, but it's easier to sort of spend a lot more time building a complicated shield. And then the other image is a satellite that's actually been involved in a like debris collision, and the solar panels on the right-hand side, they didn't work anymore after that. They are completely crooked. So yeah, telescopes also require perfect condition. Like if they're a little bit scratched, all the images just come back like completely blurry. They're basically useless. ISS has to evade debris like multiple times a year, and then the astronauts actually have to retreat to potential like lifeboat spacecraft just in case. It's actually happening more and more frequently in recent years. So what happens if debris continues to accumulate? There is obviously the theory that space could become impassable. It's not quite like as urgent as an idea, but it isn't like a complete idea that we can rule out just yet. Like that is a definite possibility. However, we still have a good window to sort this all out. So, developing a solution, the more optimistic part. So we've got a couple of potential solutions that people have been thinking up. We've got a lightweight parachute that is, the photo I think doesn't do it justice of quite how massive it folds out to. It gets packed up, the material is so thin, it gets packed into a size, about a small suitcase, about that big. And then it expands to about the size of a football field, and that acts to actually slow down objects enough so they can re-enter the atmosphere where they just burn up, and significantly less dangerous. Also use lasers, and also like little satellites that we can go and launch, and then they'll grab debris and then send it back. There's a lot of ideas. Also, we've got Whipple shields that sort of break apart debris, and overall they do a lot less damage afterwards. Then how will we be affected? Satellites very likely to become damaged, non-functional more quickly. Also, potential disruptions to science research. So we've got astronomy, where we've got radio astronomy. Satellites actually transmit it in a lot of the really important frequencies that radio astronomers use to sort of detect what elements might be on another planet. And also there's issues collecting weather and climate data, because they actually need to observe things over an uninterrupted period of time. If a piece of debris passes by a satellite in that time, the data becomes a lot less useful. And there are also growing ethical and social concerns in the media, in that is space even really asked to pollute? It's definitely a question that I feel like I can leave you with, but yeah, that was my APQ.
Thank you. So we've heard from 3 of our upper 6 students. We have a larger panel of students here who we will hear from later about sort of their experiences at college. But for now, we're now going to move on, and I'm going to introduce the first of our 2 external speakers. This is Holly, who is a senior statistician at the Institute of Cancer Research in Sutton.
Thank you for the introduction. So, first of all, thank you all for being here today. I think events like this are really great to kind of learn a bit more about what sorts of things there are. And I know I was very fortunate when I grew up, so I had a very supportive family, a very supportive school, and I was never under any impression that there was things that I wouldn't be able to do just because I was a girl. And it's only in the more recent years when I've done more of these events and I've talked to more people and met lots more people working in science that you hear these stories about people who haven't necessarily had that background and have been told, you know, oh, you know, you're always going to find this harder because you're a girl. Girls aren't as good at science. Girls can't do maths. And so things like this are great to see that actually we do maths, we do science, we can do it, and we can have really successful careers doing it, and we can really enjoy it. And there are opportunities out there. And I think quite often it's hard to envisage yourself doing something if you don't see other people who represent you doing the same thing. So when I was at school, I really enjoyed maths. And as far as I was aware, I was going to be a maths teacher, because my options that I was aware of was being a maths teacher or going into accounting or finance. And the second option didn't seem interesting to me, so no offence to any accountants or finance people who are watching. So until I was at university, that was it. My career was set, I was going to be a teacher. Obviously, you can see from my first slide, that's not what happened. So I thought I would start just telling you a little bit about my career path, so what I've done to get where I'm doing, and then I'll go and talk a little bit more about what my job actually involves to give you a bit more information about that. So I obviously knew that I wanted to do maths, as I said, so I went away and did an undergraduate degree at Bath University studying mathematics. And it was when I was in the first year kind of doing some of the statistics modules, I found out that the university offers a year in industry. So in your third year, you get the opportunity to go away and work in industry for a year. So you can go away, work with a company doing something involving your degree, so something in maths or statistics or physics. So in my third year, I went to a pharmaceutical company called Eli Lilly, and I spent a year working as a medical statistician, so working with clinical trials, analysing the data. And I decided this was really interesting. So it was medical research. I was doing something that I felt was really useful. I could make a difference to people. I was using my maths and statistics skills, which was something I really enjoyed and knew I always wanted to do. So I did the placement year and I talked to lots of people there to kind of find out a bit more and find out other options and what I would need to get there. And if you want to do this kind of work, you need a master's degree. So I went back and finished my undergrad and picked up as many of the statistics modules as I could. And you do a project in your final year, or you have the option to do a project in your final year. So I did a medical statistics module looking at, so patients were wearing kind of activity trackers, and it was looking at how shift work affects people's attention span. Because there's been some research that shows that actually working shift work can have the same impact as drinking alcohol. So in terms of people's attention span, it can have a really big impact. So I was analysing some data from a study in my final year project, which again really encouraged me that this type of research, this type of statistics was something I wanted to go into. So I then went and did a master's at Southampton University, where I studied medical statistics. And then I've been quite fortunate since, so I went straight from my master's degree to the job that I'm currently in. So I started working at the Institute of Cancer Research as a medical statistician, and I've since kind of worked my way up since then as well. But in my job, I get to do lots of research, and I decided I really quite liked the research side of things. I enjoyed the projects that I'd done at university, and so I kind of toyed with the idea of doing a PhD. When I first started at the ICR, I didn't really know what I was interested in. A PhD is 3 or 4 years of intense study, so it's got to be something that you're really, really interested in, because it's a long time to focus on the same subject. So one of the projects I worked on when I was a medical statistician, I found really interesting, and I'm going to talk a bit more about that later. And I was fortunate that they actually developed a PhD project out of it. So a few years ago, I also started doing a PhD through my work. And again, so I'll talk about this a bit later. Just to note as well, so I've had a fairly straightforward career path, so it's kind of been very linear. I've gone from one thing to the next, always working towards kind of a common goal. But that's not the case for everyone, and that's absolutely fine too. So some people will jump around. You can work for a few years and then go back to university. There's lots of different ways to go into these kind of things, and you've just got to work out what it is that you're interested in and go after it, really. So a bit about the Institute of Cancer Research, what it is and what I do. So the Institute of Cancer Research kind of does what it says on the tin. So we research every aspect of cancer. So we're kind of part a charity and part a university. We're a research organisation, and we cover everything from drug discovery to understanding how cancer evolves, and understanding how it develops and which genes are involved in the development of cancer. Within that, I work in the Clinical Trials and Statistics Unit. So we sit within the Institute of Cancer Research, and we're based at the site in Sutton. And we're an academic clinical trials unit. So we run studies to test new cancer drugs, and we work across different types of cancer, so breast cancer, prostate cancer, lung cancer, and lots of different things. So we help to design and coordinate the clinical trials. So we don't actually have the contact with the patients. The patients will all be seen in the hospitals by the doctors, but we do the kind of design and organisation side of the trials and analyse the data. So my role as a statistician, so the life cycle of a trial is very long. These trials can run anything from like a few years up to 15 years, and sometimes even longer. And I've put up here the kind of different stages of the trial. And I think quite often people, when you say that you're a medical statistician, they think this is what you do. So you come in, people run the trial, they send you the data, you analyse it and send it back. But the reality is actually quite different. So we get involved the whole way through the clinical trial cycle. So right at the start, statisticians are involved in helping to design the trial. So we help to define what the endpoints are, we help to decide what data we need to collect, how many patients are needed, and what type of trial to run. Setting up the database, so we're obviously going to be analysing the data at the end of the study, so it's really important for us to understand where that data's come from. It makes it a lot easier if you know what were the questions that were asked, how is the data expected to be entered into the database, because it helps you understand what you're looking at. When the trial's ongoing, we're still involved in a daily basis, so we help to monitor the data to check that things are appropriate, checking whether patients are following the protocol the way they should, if there's outlying data. We also have data monitoring committees, so with clinical trials, we're obviously giving real patients treatments. So we need to make sure that that's safe and we're not putting patients at risk. So we have monitoring committees who will monitor the ongoing data that's coming from the trial. So they will look at the efficacy and the toxicity of the drug, and they'll make sure that actually the benefits are outweighing the harms. So the statistician's role in that is we prepare the report for it. So we'll provide interim analyses on the study to the committee, and we'll discuss it with them. And that will happen throughout the trial. Obviously, we then get to the bit that everyone thinks of, so the analysis part of it. But you can see it's actually quite a small part of the overall work. Once the analysis is done, we help to prepare abstracts, we help to prepare the scientific papers and present the work. And then a lot of our trials, so although we may treat patients for a couple of years, in the early disease setting, we'll actually follow those patients up for 10 or 20 years after they've had their treatment. So we're still going to be collecting data for a long time, even after we've reached the primary endpoint. And nowadays, we collect a lot of biological samples as well. So a lot of our studies will have translational endpoints that will then start looking at some of the more interesting things. So trying to dig into, can we identify which patients are most likely to respond to treatments? So this is really what makes my job really interesting. So there's lots of different aspects to it. I'll work on any number of trials at any given time. So depending on where those trials are, I'll be doing something different every day. And it also means I get to work with lots of different people. So I work with clinicians, I work with patient representatives, laboratory staff, I work with the data managers and trial managers. So I'm interacting with lots of different people, getting lots of different ideas, and it's really varied work as well. It's not simply sitting at my desk all day running analysis. It's not just looking at numbers, there's a lot more to it than that I think people don't always realise. So I just wanted to give a little example of a project that I worked on, just to hopefully convey why I find this so interesting and why it's an exciting thing to be working on. So I worked on a trial called the TNT trial, and this is in a subset of patients who have a particular type of breast cancer. And unfortunately, this is a very aggressive type of breast cancer. And this is in patients where their disease has got advanced and metastatic, and there's really not many treatment options for these patients. So we randomized patients between these two treatment groups, and these are just two different types of chemotherapy. But the idea was, so the drug in orange it works in a slightly different way, and we thought that these patients might actually respond particularly well to this drug. So overall, and slightly disappointingly, you can see that there was actually no real difference between the two treatment groups. The response rates were pretty much the same. But one of the additional aims of the study was to see, as I said, we have lots of biological endpoints. So we wanted to see whether we could actually identify particular patients who might respond. And you may have come across in the news the BRCA genes. So this is the gene that Angelina Jolie found out that she had a mutation in. So it leads to an increased risk of breast cancer. But it also means that we can target this in the treatment. So when we looked at patients who had this particular mutation, we could see that our response rate has jumped from 31% to 68%. So these are patients who, before this trial, they had very few treatment options. There was not a lot we could do for them. And this trial, it found that there was actually, for some patients, we could actually treat them much better just by switching the type of drug we were using. And this was a really big deal. So we wrote the paper up, and then it got picked up by different news agencies. Because it was such a big thing, it led to a change in the way that we treat patients. And the amazing thing for me was I was the first person to see this. So I analysed the data, I saw those results before anyone else. So I was the first person who knew this. And that's kind of one of the reasons that it's really interesting being a statistician, because you are the first person looking at the data, and you're the first person who gets to see these incredible results. And sometimes, like we saw with the main trial result, it can be disappointing. But then every now and then you get these studies that really work, and it can lead to a change in the way that we treat patients. And this is the project that's actually led on to my PhD project. So we're now looking at lots of other data. So we've got lots of RNA sequencing data and other information that we're looking to pick out other patients who are likely to respond. So I just wanted to comment very briefly. So as well as working on clinical trials, from my job I get to get involved in lots of other things as well. So I'm part of our Twitter group, so I get to help produce content for our Twitter team. I get to present my work, and actually next month I'm going to the USA to present my PhD work at a conference. So there's opportunities for travel at conferences. I work on a number of working groups and external groups, which mean that I get to help shape what the priorities are for research. And actually my career is almost on a complete 360. So because I work in an academic institution, I get to do the teaching that I always thought I was going to do. But I don't have to do all the paperwork that goes with it. So I get the interesting bits without having to do the other bits. So I just wanted to end on this slide. So I've added some pictures of some of our team at various social events. And I just wanted to put these up here because you may notice that actually there are a lot of women here. So where I work, the majority of people are women. So this picture here, this is our director, our 2 deputy directors, and one of our team leaders, and they're all female. All of our principal statisticians are female. So there are lots of opportunities out there, and you just have to go and find them. There's lots that we can do. So thank you.
Thank you, Holly. Always great to have you here, talking about the fantastic research that you're doing into cancer trials. Our next guest speaker, I'm going to introduce now, is Pippa Kendrick, who is a senior consultant at Fraser Nash.
Thank you. Hi, everyone. Thank you. Yeah, I'll just echo Holly's points about thank you all for coming, and thank you to the school for putting this on. It's really important to get females to realise that there is a valuable career for them in the STEM subjects, and that they can do as good a job as anyone in there. So I'm here today to talk a bit about what I do. I work in engineering and try and dispel the picture of the stereotypical female engineer. I am a senior program and management consultant at Fraser Nash Consultancy. We are a large engineering consultancy company based in the UK, and basically we solve problems that our customers can't solve themselves. So any of the big engineering names that you've ever heard of will come to the likes of us with something that they can't solve in-house, and we get to work on the really challenging projects for them. So my aim of the presentation is to dispel that stereotypical image of a female engineer, which is probably the picture on the left that you've currently got in your mind, and open your minds that it can be a rewarding career for you to go into. I'll just run through what an engineer does and what they are, some projects that I've worked on, how I got to where I am today, and why you should think about a career in engineering. So just to start with, this is, really simple Google search of what's an engineer, and these are the pictures that the media put out there of largely men in hard hats, largely on construction sites, holding some sort of clipboard or large piece of paper, site drawings. This is what the media portrays as what a typical engineer looks like and therefore what they do. Again, if we go into female engineers, when it goes, very, very similar, yeah, okay, females wearing the hard hats, but very, very similar image. And I'm here to tell you that there's so much more in engineering than what those individuals do. Yes, they're engineers, yes, they do it, but there's so many more things you can do in the sector, in the field, than largely construction that they are working in. So, this is more like it. In 2017, the Institute of Engineering and Technology ran a campaign called The Portrait of the Engineer. These are 10, 11 females that are under 35, top of their game, were in the top 10 to win the Young Woman Engineer Award that year. That is what an engineer looks like, and I'd like to think they look quite glamorous, because that's my opinion anyway. And that is more representative of the spectrum of people. So, moving on to what does an engineer do? This is a really historical idea of what they've done, that they are people that design, build and maintain engines, equipment, machines, structure, that kind of thing. But I'm here to tell you that there's so much more that you can get involved in that field. Engineers are the people that will solve the challenges that the world is facing today, be that food and farming challenges. On the news today about there's a shortage of eggs, they'll get involved in that sort of thing, farming, transport, housing, energy and renewables, obviously really topical, where's our energy supply coming from, climate change, how are we getting our energy in a sustainable way, how are we solving what the state the world is in currently, manufacturing, shopping habits, healthcare and medicine, communications, space exploration, which we've touched on, obviously, and yeah, social media. So many different things that you can do in any of those fields beyond structural and civil engineering. That is definitely a field that you can do if that's what interests you, but there's so many words on the right-hand side, right-hand side, of types of things that you can do, be that software or cyber, environmental engineering, material science, design stuff, be the person that comes up with the requirements, project manager, that is what I do. So I am the person that we define the scopes of a project, any project, and make sure that it runs on track, to budget, to deliver what it's meant to deliver. Human factors, safety engineering, asset management, there's so many, I can't get them all on that slide, but the realms of different things that you can do within the engineering sector are endless. So what do they really do? They make things happen. They will solve the problems that the world is facing today and make things happen. So a little bit about projects I've worked on. I've been at Frazer-Nash for 8 years, so I can't cover everything. I couldn't even count all the projects that I've worked on whilst I've been there. But three to talk through in a bit more detail. I worked on a central line project which looked at how we could make the maintenance that the trains undergo more efficient, to make the trains be more available, be in the workshop being maintained less and more available to be on the lines running. I really enjoyed working on a project that I could sit around the dinner table with my friends out for a dinner and say, I'm working on a project that will help your commute be more smooth in the morning. It was really great for people to be able to see how the work that I do can affect them and improve their lives. Slightly more glamorous, worked at the Foreign and Commonwealth Development Office in central government. So the SCDO have embassies all over the world, and they have thousands of projects going on within those embassies to maintain them, improve them, build more facilities, whatever. We set up a project management office, which was a hub that made sure all of those projects ran smoothly and were ran in a consistent way, reported on and tracked in a consistent way. And then the final image they are 3 big liquefied natural gas tankers. I am currently seconded to National Grid and working at a liquefied natural gas plant in the mouth of the Thames, where ships will come in with gas in liquid form from wherever in the world it's been retrieved from. It will be pumped into these storage containers, which are, each one is bigger than the Royal Albert Hall for scale. And from there, the gas is gasified, so into gas state, and pumped into the national transmission system and comes to your and mine homes. So this gas terminal on the mouth of the Thames is the biggest liquefied gas terminal in Europe, and will be really, really important to securing enough energy to heat our homes this winter. So really topical to be there at the moment, and yeah, really great to be able to have a hand in making sure that again, another thing that affects our daily lives is sustained. So how did I get to where I am? GCSEs, I had no idea what I wanted to do, and through all of this journey, all I've ever done is made a decision based in the moment and time and what I enjoyed. So when I did my GCSEs, I didn't actually even do separate science, I did dual science. I didn't know that it was science that I was going to go into. I then enjoyed my science subjects at GCSE and chose to go maths, further maths, physics and chemistry at A-level. Again, then went, what degrees can I do? Interested in, work with like-minded people, which is actually really important when you're spending all day, every day with them. The marine engineers are in real high demand. It is, especially in the current climate, important that you head into something where you will have some job security, and you definitely will, especially given the stats that were up at the start of the evening. It can be well paid, and you can climb the career ladder pretty quickly. Hopefully I've demonstrated that earlier. So why should you think about career in engineering? Sometimes it's glamorous, it's always good fun, and sometimes you do get to wear a hard hat if you want to. That is everything.
Thank you very much, Pitha, and thank you, Holly, again as well for speaking this evening. We are going to hear very shortly from Nikki Robinson, our head of physics. But before we do, I'd like to introduce, or at least get our panel of students, sort of briefly introduce themselves and talk a little bit about sort of the subjects they do and why they do them here at college. So if we start at this end, you can just, you should be able to speak just into the mic.
So hi, my name's Eva. I am studying chemistry, biology and psychology with aspirations to go into medicine. So I think medicine, people kind of have the idea that women are really represented in medicine, which they are at degree level, but I'm really passionate about getting to the top of medicine where it's mainly male dominated. So yeah, women in STEM has really helped that so far.
Hiya, you met me earlier, I'm still Angie. As I said earlier, I do English Lit, physics, chemistry and maths. When I started college, like basically everyone, I didn't know exactly where I wanted my life to end up. When I began college, I did have more of a focus on chemistry, but currently physics has gotten to a very fun part. We're looking at fundamental particles and stuff. I've just sent off my UCAS application, so I applied for chemical physics, which is another thing you don't think exists. There are so many degrees that exist that you wouldn't expect, but chemical physics and then separate degrees in chemistry and physics as well. So I'm waiting on that at the moment, but yeah.
Hiya, I'm Sophia and I'm doing biology, geography and English literature. So I'm doing quite a variety of subjects, but I knew that I could do biology and geography and go into a degree in biological sciences, but I still wanted to keep my options open with the English literature. So I'd just say my one piece of advice is to do subjects that you enjoy because you'll probably be better at them. So, yeah.
Hello again, my name is Maeve. I didn't say earlier, but I do computer science, physics and maths, so I'm very full on with the STEM subjects. I'm actually currently one of only 2 girls in the computer science course, so it's very male dominated with subjects like the ones I do. I actually came from an all-girls school, so it was a very big change for me, but I really enjoy what I do. I'm hoping to go into engineering, and the college has supported me so much with doing women in STEM, and you know, it's very fun to do subjects which kind of defy the stereotypes that your society puts on you, so it's quite fun. Yeah.
Hi, yeah, so Laura still, as I said before, I do maths, physics and biology, and I am an upper sixth, so I'm applying for natural sciences at uni, and I'm hoping to sort of focus that on earth and environmental sciences, because if you couldn't tell from EPQ, I'm quite into all that sort of conservation, sustainability sort of thing. That's sort of what I'm hoping to do in the future. But I think the college has been so helpful in terms of like having all these opportunities, Women in STEM, Aspire, EPQ. It's like you just have all these opportunities just thrown at you, and it's like so many just chances to develop sort of your idea of your science subjects combined with like your like personal interests, like space stuff, like that I did my EPQ. I was so glad that I had the opportunity to do that in my EPQ. So, yeah. Is that on?
Yeah, hi everyone. I'm Gwen. I take maths, further maths, chemistry, and psychology. I kind of just took my subjects because the ones I enjoyed and the ones I was better at. I think it's just take subjects that you enjoy. I know everyone said it, but it's kind of the only thing you can do if you don't actually know what you want to take or what you want to do in your future. Just take what you like now and then decide in a few years.
Lovely. Thank you. So later on, we should have time today for any of you to ask any of our panel here, whether it's students or our speakers, any questions you might like. But for now, let me introduce Nikki Robinson, our head of physics, and doing all sorts of very fabulous things.
Okay, thank you very much indeed. Thank you for the introduction, and thank you both for setting me up so well. That's absolutely fantastic. I was one of those people who wore a hard hat. I had rigger boots. I entered engineering at a time when there really weren't many females. So you couldn't even get the clothes. They were all men's clothes. My high-vis jacket was down to my knees. My hard hat didn't fit. It was too big. I had a boiler suit. Did you ever have to wear boiler suits? Yeah, okay. So it was for a man, and so basically I had to take up about that much on the leg of my boiler suit, which meant the crotch was around my knees. So I was going round the sides like this. Absolutely ridiculous. Okay, I'm glad to inform you that things have changed. You get nicer female site clothes now. It's all good. Right, I'm hoping that there is a presentation. There is. Good. Okay. Right. It is fantastic to see you. I'm going to tell you a little bit about my journey. I want to, first of all, thank Pippa and Holly for their fantastic introduction. That is really, really good. I'm getting a theme from all of the ladies on the panel there and here. Do what you love, do what you enjoy, and go from there, because it's not easy sometimes. You think, actually, some of these subjects are hard. Physics isn't easy. It's not going to be an easy journey. But my goodness, it's rewarding. And by the end of your sort of, I suppose, training, you are going to be an incredibly flexible person. You're going to be a very adaptable person. You can turn your hand to anything you want to do. But most of all, you can be guaranteed that you'll have a job that is fun. It's exciting. No one day will be the same. They will all be different. And even if you don't find your niche within engineering or physics or whatever it is to begin with, because you're so adaptable, you can change. And hopefully, if you indulge me for a while, I'm going to tell you my journey through. And it will show you, hopefully, that you can adapt and you can change and you can do whatever you want. So when I chose my A-levels, it was maths, physics and geography. I did it because I loved them, just like these guys. okay? I got to the end of sixth form, and I didn't really want to give any of them up. So I thought, well, what now? Natural sciences. So there we go. Natural sciences was the next calling for me. If you don't know that place, that is the Senate House in Cambridge. So off I went to do natural sciences. I specialised in geology eventually. Don't tell college. I'm head of physics. But I did do a couple of years of physics, so all is well with the world. But the wonderful thing about natural sciences degree is that you get to choose what you want to study. You don't have to fix on anything. So I was just able to choose things I wanted to do. Why not? Go with where your heart leads you. Your head's got to be there somewhere, but go with your heart. So, got to the end of my undergraduate course, and I'd specialised in geology. Now, geologists, there are quite a lot of options in terms of where you can go afterwards, your jobs. You could become a volcanologist, a paleontologist. You could become, I don't know, a structural geologist, all sorts of different things. But the main two, I suppose, petroleum geology and hydrogeology. I knew I didn't want to go into oil, and that was a long time ago because I knew it wasn't really going to lead anywhere. So I decided to do hydrogeology. And hydrogeology, you've probably never, ever heard of in your lives. I'm looking at the audience. Any ideas? No? Maybe you do. So hydrogeology is the study of how water flows through rocks. You need a lot of hydrogeologists out there, actually, because they study both the volume of water, i.e. how we can use that underground water for our drinking water supply, and how it interacts with rivers and streams and keeps those rivers and streams flowing. We need them also to help with the quality of the water that we drink, protecting that quality of water. That is so important. So imagine you've got a spill, I don't know, the M25, tanker goes over. Where is that oil going to go? Oh dear, it's going to go straight down to the chalk and your drinking water supply. So as a hydrogeologist, we would rush in and go, right, panic, let's clean it up and let's find out what we can do about it in the long run to stop that from impacting your water supplies. So as Pippa said, a lot of what we do is about making people's everyday lives easier, happier, smoother. Okay, and so off I went. I did an MSc in hydrogeology, and I thought, well, what next? Well, clearly I'm going to go on site, aren't I, with my hard hat and my boots and all the rest of it. And so I did do that. I was that person for a while, and it was good fun. It was certainly interesting. It was wet and cold occasionally too. So after a while I thought, actually, do you know what? I'm going to go back to UCL and I'm going to go and do a PhD in hydrogeology. So I specialised, I became even more niche and I did fractured rock hydrogeology. So stuff the sandstones and the sands, I was going to go straight for the chalk and the hard stuff. Okay, so that was me. So I've been involved in all sorts of projects, just like Pippa and Holly. That one you might recognise if you've ever been down to Portsmouth. That's the A3 Hindhead Tunnel. So I helped to design how that was drilled, because there were a couple of groundwater abstractions really close by. And if you drill a great big tunnel through a hill, you're going to churn up all of that rock and create horrible turbid water. So you turn on your tap and it would just look really cloudy. You're not going to want to drink that. So it was making sure that that drilling process was good and smooth. About that time, I got involved in the Geological Society. Now, I noticed that, Pippa, you are a chartered engineer. I'm a chartered geologist. So each profession has their own body that ensures the standards of that profession. So, i.e., as a geologist, if I did not do my job properly and I don't know, made a complete mess of it, they would basically strike you off, a little bit like a doctor, and say, no, a supply well that's kind of not so very far away. Do you have a problem with that? Or are you okay drinking bodily fluids? Okay, so when you expand a cemetery, you have to make sure that all of that that we don't really want to talk about isn't going to impact your drinking water. And so that's another one of the things that I do, okay? Random stuff. About 12 years ago, I decided to retrain as a teacher. The reasoning for that? Within my previous job, I was doing a lot of training, and I discovered that actually I really loved teaching people. And I thought, well, there's a bit of an itch to be scratched here. Let's give it a go. And then here I am now. I've done all sorts of things. So I've taken people out for astronomy evenings. I've learnt that. Didn't know that before. You see, I want you to see that you can be really flexible and adaptable and do completely new things. So there's that. What else? Oh, some of you, I don't know, did you come to the open evening back in October? Did anybody come into physics? Did you see the fire dance in the tube? Maybe some of you did. Okay, so there's something called a Rubens tube. It's a big long tube with little holes along the top. Fill it full of gas, light the gas, put a loudspeaker down one end, and you make the flames dance with the music. Oh, that's quite cool, really. So I like to play with fun stuff. That is an infrared image of me behind the Rubens tube. So you've got 103 degrees. You can see the flames coming out of the top. And then me behind with an incredibly cold hand. Can you see it's really blue? It's really cool. Anyway, sorry. Getting a bit excited and geeky. Right, so that's a summary of me. I've done loads and loads of different things. You could do that too. So you don't have to start off really narrow and stay narrow and go even more niche. You can say, no, I want to do something completely different. Why not? Fancy a change. And with your STEM qualifications and your training, you can do that, okay? Now, I would imagine that Simon, Holly and Pippa have already said this, but actually, ladies, you are amazing, okay? You're better than the boys. Shh. Okay, sorry, Simon. Okay. So, within physics, biology, further maths, ICT, DT, we get more A star to C grades than the boys. Okay. So that's quite cool, isn't it? Okay. In terms of first and 2-1s from university, we do better than the boys as well. Okay. So don't let anyone tell you that girls can't do STEM. Oh my goodness, they are really, really good. Next thing to point out is you'll never be without a job. You really, really won't. You will find it relatively easy, even in really tough economic times, to find yourselves a job as a STEM person. And you have such a rewarding career. It's so good to feel that you are contributing towards society. And you girls have the opportunity to contribute to the really big stuff, the stuff that Pippa was talking about, solving climate change, helping to mitigate the climate change problems, looking at the energy portfolio and seeing how we should change it. How can we get, I don't know, for example, why aren't we running all on hydrogen cars? Hydrogen cars would be really cool, because all they need is water. Okay, that would be even better. Don't ask about the batteries. We won't worry about the batteries yet, but anyway, we'll go there. So something just to help prove, I suppose, that your job prospects are phenomenally good. The UK government, on a fairly regular basis, about every 6-9 months, put out something called the UK Shortage Occupation List. And what this is it's aimed at people from overseas who think, I know, I want to come over to the UK. Will they let me in, though? And so if your job, your training as an overseas person is in one of these different aspects, then we will welcome people with open arms. And you will start to see that there is a massive theme going on here, okay? I've not printed out all of them, okay? But out of the 31 categories listed by the UK government, 19 of them are STEM related. That's most of them, all right? We need physical scientists. We need hydrogeologists. Look, see, that's why I'm still doing it. We need them. It's good. We need geophysicists. We need civil, mechanical, electrical engineers. And if you were in any doubt, if you look at the bottom two, they really do need electrical engineers because they've said it twice. Okay. More on the list. Loads of, oh look, some more engineers. And if you're in any doubt, second one down, even more engineers. If we've not listed them, we want you. Right? We definitely want engineers, please. IT people, web development, all needed. Vets down at the bottom there. That's not being rude, sorry, that was just a coincidence. But we need all of these fantastic people. So you can see, and I've been looking at that list for probably, I don't know, probably the last 10 years, something like that. And it's always been the same. Most of it is STEM related. So really, you won't have problems finding a job after your degree. Some good news for you as well. So unlike me, when I started off in my journey in the world of work, there really weren't that many females in the engineering industry, hence the lack of kit. You know, you can imagine me shuffling around the site with my kind of crotch and my boiler suit down here. You know. It's not a great look, really. It doesn't look professional. When I started out, I would turn up to meetings, I would turn up to conferences, I would turn up to site, and they would say, oh, I'm expecting Dr. Robinson. Yeah, I'm Dr. Robinson. They're like, oh, we expected a man. Oh, sorry to disappoint. Now, the good news is that I'd say about the last 15 years, that has never, ever happened. It has completely changed for you. So I think that is absolutely wonderful. So you can see the positive news here. We've gone up in terms of those working in engineering from about 12 to 15% just in a matter of 6 years. So it's slowly climbing. This is all good. We've got 25% increase in engineering occupations just in 4 years. That's brilliant. And look at the numbers. Nearly 1 million engineers. Oh, brilliant. Okay, so we will rule the world soon, but just not yet. Bit by bit. Bit by bit. Okay. And here's the sort of things you might want to think about. I mean, Pippa's already said these, but you've got such a fantastic opportunity to have input into the really big problems, into helping solve them or mitigating them. Mustn't forget the ethical problems behind things, so we must always keep that in mind. As a chartered person, you must always keep an ethical mind. You can't just sort of blunder into something. So is it okay to just capture all that carbon dioxide and stuff it underground somewhere? Is that a good idea? I'll leave that with you, okay? There we go. Oh, I was going to show you some of our lovely people. So we have this fantastic panel here, and I'm sure that you will all become poster ladies in not too distant future. But these are some of the others that have left us in the last sort of 2 or 3 years. So we've got Deborah here, who's gone off to do chemical engineering at Loughborough. Loughborough is a fantastic place for chemical engineering, by the way. She studied chemistry, maths, physics, and Spanish, just because she could, and she really enjoyed it. So there we go. This is Jess. More of a typical profile, I suppose, and A-levels, maths, further maths, physics and geography, and off she went to do mechanical engineering at Imperial. We've got Sophie. She didn't do perhaps what you would think of as a typical portfolio of A-levels. We've got a BTEC in there, BTEC in engineering, and she's gone for fashion and textiles. She's gone with what she really loves. It's fantastic. It's what you do because you'll be so motivated in that particular subject. And goodness knows you'll be spending a lot of time doing it. But she's gone for that and then gone into cybersecurity with a degree apprenticeship. Brilliant. Okay. Degree apprenticeships. Have you heard of degree apprenticeships? Yeah, somebody? Brilliant. Bit of a bonus, you don't have to get into student debt. Your company pays for you to go to university and you still get a degree. What's not to love? They are quite highly fought over though, so they're very competitive. It's well worth looking into. We've got Freya, who went into music and sound recording at Surrey. Surrey, just down the road in Guildford, one of the best universities in the country now. Very, very good. Lauren, off to do product design at Brunel. Who else we got? And Laura from last year, and she's gone off to do natural sciences too. So obviously she couldn't make up her mind either. But you don't have to either. So that's really good news. So I hope that's helped you see, well, if you didn't already know, that by heading off into that STEM career, that you will become a really flexible person, adaptable person, with really good, strong problem-solving skills. You can go and do whatever you want, okay? Dream big, why not? Just go and do it. And hopefully you can start your journey with us in your STEM career in the next year. Thank you very much, everyone.
And thank you, Nikki. So that's it from our speakers today. So can we give all of our speakers and our panelist students another round of applause? So we've got about 10 minutes or so left. So what I'd like to do is open up to if you have any questions at all for any of our panel here. Don't all shout. Okay, well, maybe just to kind of start off then, I'll ask some of our students. So here we've got a mixture of first year, so lower six students and upper six students. So I think possibly something that we often get asked at events like this for our lower six students is, how have you found the transition from school through to college? So anyone?
Yeah, okay, I'll take that one. Yeah, so I think the transition has actually been really good. Like, college has been really good at supporting everyone through the transition. And obviously it is quite a change from, you have quite a broad, like you do a lot of subjects at GCSE, we did like 11 or 12 subjects at GCSE, down to 3 or 4 is quite a big change. But I think it helps quite a lot, obviously picking subjects that you love, which everyone decides, but you get to be more focused on the subjects you actually enjoy, and you get to just have a deeper understanding of everything. So one thing that I found so far with maths already is that everything's starting to link up a little bit more. So obviously when you do GCSE maths, it's just like, this is one thing, this is another thing. But with A-level maths, you just get a little bit deeper into everything, and you kind of get the reasoning behind it a bit more, and it's just a bit more interesting and like a fuller understanding, I think.
Okay, thank you. Anyone else?
I think the college has been really good at just guiding us through, because it's quite a different style of learning at college to secondary school. There's much more freedom. You do a lot of studying in your own time instead of in lesson time. So the college provides a lot of support for this. And actually the Women in STEM kind of society is a really nice place to go and get your chemistry or physics or maths work done with similar people who are interested in the same things. So I think that's been really good at helping with the transition, because it is a big jump. The subjects are much more advanced, but things like this really help.
I was just going to add to Gwen's point about it being a more deeper understanding of all of your subjects. I find that in biology in particular, there's so much content, but I know so much more than I did at GCSE, and if anything, that's so motivational, because now it's kind of inspired my passion for biology even more. So I'd say, even though the jump is quite big from secondary school to college, you find that you become much more inspired in your subjects, and you begin to enjoy them a lot more.
Cool, lovely. So, and then maybe for upper six students, we've heard a lot about university and kind of that process with a lot of our students who Nikki showed up there, sort of going off to do all sorts of things. How have you found the process of picking what you want to do?
So the college provides a lot of support when you're trying to decide what to do. You have tutor sessions, mainly like focused on UCAS, and careers. The support from careers is just phenomenal. They're such a good department, and they show you, like, literally they show you all the steps that you go through when you're applying to UCAS. And picking your subject is like it's a really hard decision because you obviously want to make the right decision, but I think throughout this whole year of second year of college, I think I've changed what I want to apply to uni for about like 5 times. So like I've got in like, you know, I wanted to do just like pure engineering, and then I changed my mind and then changed my mind again. And like, so it really, changing your mind isn't really a big deal. Like you can get your UCAS back, you know, you get a lot of support and you get so much information about what you're doing, and they provide so many talks and lectures that you can go to. You know, they show you all the open days that are available to you for universities, and so they give you as much information as you possibly can have to make a decision. And although it feels like, you know, it's a huge decision, which it is, but they give you as much support as you possibly can have to make that decision.
Laura, Angie, anything to add?
Yeah, I was just going to say that was a really good point. The careers department at this college are like laser focused. I don't know at like GCSE if you ever took like a careers quiz and it gave you, I think I got like drama therapist at one point. I was like, oh, okay. You go to the careers department here and they lay out like, okay, dramatization, there's a blueprint, there's 7 steps, this is the breakdown, this is what we're going to do, and this is how we're going to help you do it. It's just an amazing support system. And like, what careers also do that you should also hold for yourself, you don't have to stick to any big plan you had set out for yourself. Part of the fun and joy in life is being a bit mercurial. Maybe one week you're like, I love my biology, I understand. And then next week you're like, I hate it. I'm actually going to do chemistry. Yeah, that's the plan. You know, the college is meant to support you doing what you love, and they try as hard as they can to do that. So you're going to start the college and you won't be by the end of college, you won't be the same person you were, in a good way. But, you know, you are going to change your mind many, many times. But that's okay, because the college is here, friends are here. And yeah, you can change your UCAS so many times. And also, you know, halfway through your life, you decide you want to change, be a mature student, do what you want to do. You could be 30 and be like, I'm a doctor now. You know, do you.
Yeah, no, but just to add on to that as well, like, definitely the whole changing your mind, I think that is such an important thing. Like, I have changed my mind about 100 times in about 100 different ways since starting at college. I think I dropped the same subject twice. I've dropped 3 subjects total, one of them twice. And I think I've gone through about 100 different degree options, different careers. I don't know what job I want to do, so I just decided not having a decision was safe for that one. Now I'm saving that one for later. But I've changed my mind hundreds and hundreds of times on literally anything I could have a choice on. I'd change my mind on it. But I think every single time I've been happier than I was before it. Like, the college has supported me so much. Like, I remember with my EPQ, I picked the question for it the day after an important deadline. And I remember emailing my teacher like, hey, I want to change my topic, is that all right? And she was like, yeah, do that. And then she like helped me all the way. Like, she's like, right, make sure you just get this done now, and then just make sure you've got an idea of what you want to do and all this. And like, I just felt so supported with all of that. And yeah, every time I've changed my mind on something, it's always felt like the right decision. And I think, yeah, that's, if there's one thing I can say, is don't ever be afraid to just change your mind on something, because obviously, like, nothing bad about any of the subjects and things that I've done, like, they're really important to me, but I'm really happy with where I am now, definitely.
Lovely, thank you. So just before we finish, are there any last questions from anyone? Yes. So what is EPQ? So the EPQ is an extended project qualification. Depending on kind of your GCSE, your average GCSE grades, you'll either do it potentially in your first year here, as our 3 presenters here did, or you might do it in your second year here. It is a small research project. I say small, it's not that small. It's not small. It's a research project. You pick whatever topic you're interested in, and that's kind of great exhibited here with 3 very different topics. You research it, and you do a sort of project written up and do a presentation. What's the benefit of doing it?
I think Angie actually touched on this when she was speaking, but I wouldn't consider an EPQ as one of your GCSEs, although it's quite a lot of work. You've got to remember, it's you pick the subject, and so you're obviously going to pick a subject that you genuinely enjoy and you're passionate and you're interested about. And I don't want to speak on behalf of Laura and Angie, but I personally didn't find my EPQ that much work, although I did a lot of work for it and put the hours in. I was genuinely enjoying reading up on it, researching it, and even writing it, although it caused a lot of stress sometimes. I was genuinely enjoying it. So although it's like a whole other kind of subject, some people say that, and you do a lot of work, it's really fun. So I wouldn't actually consider it to be like a GCSE, another A level. So yeah, but I would definitely recommend doing one.
Yeah, so what's the benefit of doing an EPQ?
You get to, you learn loads of things actually. So I am doing mainly like STEM subjects. So I actually don't do a lot of writing or essay writing or like any of that. I'm sure that will become a lot more relevant when I go to university. And if I hadn't done an EPQ, I wouldn't know how to reference, I wouldn't know how to structure my research, analyze it, evaluate my work. You know, you do a lot. All of that you get to learn while you're doing an EPQ, and you know, you're told how to do all that stuff.
Lovely.
Yeah, I've got my own set of benefits. I mean, my favourite one is that I've got a whole bunch of like science trivia from it. Like, I've got so many fun facts now in my head that I can give you. But also, again, with Maeve's point, I really found it useful to actually have a chance at writing something a bit longer and having to like cite it, because I think that is something that I should probably know how to do for the future. But I think generally though, it's just such a good opportunity to like develop what you're interested in, because as I said, I changed my mind a lot. I think when I started my EPQ, I wanted to do engineering, and then I wanted to do astrophysics. And then that sort of encouraged me to apply for a work experience at UCL Minor Space Science Laboratory. And then while I was doing that work experience, there was a talk from a lady about astrobiology, which I was like, oh wow, I want to investigate that more. And then that's what took me into Earth, where I was like, oh, Earth science is actually really interesting. So it takes you on quite a long path, but I think it's generally just so interesting and a good opportunity to just develop your interests a lot more.
Angie, any final thoughts just to finish us off?
Yeah, I'll be brief. I think when you're considering EPQ, you want to think about the things you bring to it and the things you take away from it. As for bringing to it, it's something we've touched on. Enthusiasm is the main thing you need, because at college, it's a very condensed learning time of everything, like just the progression you have in 2 years from GCSE level to be ready to work at uni level. You pick up on it quick, and it's quite a steep hill to climb. But with an EPQ, as long as you're enthusiastic, you'll be sitting there and reading how to cite things, how to correctly analyze sources. You just need to be ready to do that work. And then the things you take away from it, there are loads, as we've said. It's just writing in an academic style. It's researching. As part of the EPQ, you do a presentation at the end. So it's a lovely bit of public speaking, which I'm sure we all enjoy. It's a very fun time, not at all anxiety-inducing. But, you know, what you get away from it is also what you put into it. So EPQ, it's what you make of it.
Thank you. Now, that's 7 o'clock, so unfortunately we do have to finish there. If you do have any questions pressing and you didn't want to ask them in front of everyone else, or you've just suddenly thought about them, please feel free to stick around and ask anyone here. We've got a few members of staff, myself, Deputy Head of Maths, we've got Nikki, Head of Physics and Course Leader for Engineering, and we've got another Nikki, who is Teacher of Chemistry and Applied Human Biology. Thank you so much for coming. Thank you to those joining in the ILC. And yeah, if we can give everyone just another round of applause. Hope you have a safe journey home. Thank you so much for coming.